Chapter P, Part 3. Now we get to talk about polynomials. Polynomials are a collection of terms, which means terms separated by plus or minus. So if you look at this example, we have a plus here and a minus here. All of these are considered terms of the polynomial. The constant or constant term is the number that doesn't have a variable. So in this particular problem, the -9 is the constant. The coefficient is the number part of a term. So in both of these, you have coefficients. You have a 5 here, and in this one you have a +1. It's invisible. It's stuck in front of that y. So your coefficients in this example are 5 and 1. Then you have your variables. In this problem, you have y as your variable. Some people would go further and say that you have a y and you have a y squared. For me, it's the same variable, one just has a higher exponent on it. The degree of a term is the degree of a particular term. So we're looking at these three terms. The degree is the highest or the sum of all the exponents of the variables in each term. And that was a little bit difficult to understand, so let me say that again. It's the sum of the exponents of the variables in a term. This particular term only has one variable, and the degree of that variable is 2. So the degree of this term is 2. So if instead of 5y squared it had been 5xy squared, the degree of this term would be this 2 plus this 1. So the degree of this would actually be 3. So the degree of this term, there's only one variable, and the degree is a 1. This doesn't even have a variable, but what if it did have a y? To make it so that it didn't have a y, you would put a 0 on there. Y to the 0 power is 1, right? So this is your variable part of the constant term. That means the degree of this one is 0. So the degrees of the terms in this polynomial in the order that they appear is 2, 1, 0. The degree of the entire polynomial is the highest of all the terms' degrees. So the degree of this polynomial would be 2. A linear polynomial is a polynomial where the highest degree is 1. So something like y plus 6 or x minus 9 or something like that. The highest exponent is a 1. A quadratic polynomial is where the highest exponent is a 2. So like this one at the top. That is a quadratic polynomial. A cubic polynomial has a highest exponent of a 3. So something like x cubed plus 2x squared minus 9x plus 4. This would be a cubic polynomial. Then we have terms. Remember we just said that each of these things that are separated by plus or minus, those are terms. Like terms are where the variable parts are the same. So in this example, none of these are like terms. They do have the same variable, but these variables have different exponents, which makes them not alike. So if you had something like 4x minus 9 plus 2x minus 6x squared, you would have two like terms, the 4x and the 2x. Those would be like terms. A monomial is a polynomial with one term. So this right here would actually be an example of a monomial. It's one term. A binomial has two terms. So this is an example of a binomial. 2 terms. A trinomial has 3 terms. So this is an example of a trinomial. It has 3 terms. So what does it mean to simplify polynomials? The very first thing you need to do is make sure you know what operation they want you to do. That one's addition, this one is subtraction. This one doesn't have any sign there. That means it's multiplication. This one is division. You should always look at that first. Okay, so since we know this is addition, all we have to do is combine our like terms. This x cubed doesn't have a like term, so we keep it where it is. The next thing, if we keep going down the line, we have squares. Well, here's a 4x squared and a 3x squared. If you add those together, you get 7x squared. Then you have a negative 5x and a negative 7x. If you combine those, you get a negative 12x. So this is completely simplified. Alright, so this one, the only thing that's different is you have to distribute this negative 1 before you do anything. So you're going to get negative x squared plus 3x minus 4. Then, distributing this negative actually changes all the signs inside. Negative 1 times 4x squared is negative 4x squared. Negative 1 times negative 6x is positive 6x. And negative 1 times 9 is negative 9. Combine your like terms. Negative x squared minus 4x squared is negative 5x squared. And then you have 3x plus 6x, that's going to be 9x. And then you have negative 4 and negative 9, that's going to be negative 13. When you are multiplying polynomials, you distribute everything in one polynomial to everything in the other polynomial. So what we're going to do is multiply everything by x, then we're going to come back and multiply everything by positive 3. X times x squared, x times negative 2x, x times negative 1. Now we multiply everything by 3. 3 times x squared. Notice I'm going to put it here. That's because I know I'm going to have to combine like terms, so I just put it under its like terms, so I don't have to hunt them down. 3x times negative 2x is negative 6x, and then 3 times negative 1 is negative 3. Now I combine like terms, x cubed. This negative 2 plus 3 is positive 1. Negative 1 and negative 6 is negative 7, and we bring down the negative 3. Finally, we get to divide. 8h cubed minus 1 divided by 2h minus 1. This may be a problem you should pause and watch a couple of times so that you make sure you understand, because we will be using this quite a bit this semester. The big thing right now is make sure you aren't missing any terms. If you notice, in every one of these, the exponents decrease as we read left to right. See how this one goes 3, 2, 1, 0? You need to make sure that the polynomials on both parts of this problem decrease in exponents. If you're missing any, you must fill them in. So here we have 3 and then 0. We're missing the 2 and the 1. So you plug in the 0h squared, the 0h, and then the minus 1. What do you multiply by 2h to get 8h cubed? You need a 4 to get the 8, and you need 2 more h's to get h cubed. So we need 4h squared. I'm going to put that over its like term. Now we multiply this by both of these terms. 4h squared times 2h, and 4h squared times negative 1. At this point, you subtract this entire binomial. That means you distribute this negative, and when you do, it changes this to a negative, and it changes this to a positive. These are 0. 0 plus 4 is 4. Bring down the 0h. Now, What do you multiply by 2h to get 4h squared? You're going to need a 2h. 2h times 2h is 4h squared. 2h times -1 is -2h. Subtract again, which means it changes all those signs. So that's 0, and that's 2h, and you bring down the -1. Well, what do you multiply by 2h to get 2h? You just need a 1. 1 times 2h is 2h. 1 times -1 is -1. When you subtract this time, you actually end up with 0. So you have no remainder in that case. This is going to be your answer. That's your quotient. Just a few more to work out. In this one, we're trying to multiply. These are just multiplying binomials. So we're going to multiply x times x, x times 3y, -9y times x, and -9y times 3y. Now we need to combine these like terms. We get x squared minus 6xy minus 27y squared. You just multiplied those two binomials. If you have a little 2 like this, it means to write that 3x minus 8 twice and multiply it out. 3x times 3x is 9x squared. 3x times -8 is -24x. -8 times 3x is also -24x, and then -8 times -8 is a positive 64. So combine like terms. We have 9x squared minus 48x plus 64. Finally, this one, 2t to the 4th times 2t to the 4th is 4t to the 8th. 2t to the 4th times 1 is 2t to the 4th. -1 times 2t to the 4th is -2t to the 4th. And -1 times 1 is -1. Combine like terms, when you add those two together, you actually get 0. So your answer is 4t to the 8th minus 1. This has a really special name. It's called difference of squares. That's a really, really important thing to know for what we're going to be doing in the next section. Difference of squares. That's because this is a minus. That's the difference part. This first term and the second term are perfect squares because you had to square something to get it. 2t to the 4th squared is 4t to the 8th, and 1 squared is 1. So you could square something to get both of these.